Dr. Wallace. I am going to go over a few things that we went over in the problem session yesterday, and I will share my screen so you can see it. See what we did? Okay. So there were a couple questions about the material from sections 2.2 and 3.1 in our elementary stats class, and I answered those, but I forgot to share my screen last time I was videoing. So let me show you what we went over, and so you can see actually what we were talking about. So first question was about class width. So this is a PowerPoint presentation that's based, was created by the authors of the textbook, and it goes along with section 2.2. So what I was saying is the class width is the difference in the consecutive lower limits or left limits. The upper class limits are really only useful for showing the range of values and the accuracy with which you're going to measure your data values. So if, say for instance, all your data values are measured to an accuracy of to the nearest whole number, then you would have a class like this from 0 to 4, for instance. But really the class itself goes all the way from 0 to 5, just not including 5. So it's like 0 less than or equal to x, which is strictly less than 5. Because in a frequency distribution for quantitative data, the data is broken up into classes, and there's no space in between those classes. So the actual width is the difference in the consecutive lower limits. So 5 minus 0 would be the width of this class. 10 minus 5 would be the width of that one. 15 minus 10 is the width of that one. When you don't have another one, you look at the pattern to see what the next lower limit would be. So the next lower limit would be 20. So 20 minus 5 would be the class width. Typically, you want to make your classes the same width, if at all possible. So your histogram, which is the bar graph that's associated with a frequency distribution for quantitative data, will have all the bars with the same width. Okay. So constructing one yourself was another question, and there's homework problems about that. So let me see if I can get out of this. Okay. So let me show you what that looks like. So if you go to Connect Math in the class here, there's a homework problem that asks you to create the classes yourself. Let's see, it would be here, I think. So, there was also some questions about the shape of the data. So if you have a histogram, right, one nice thing about a histogram is that it shows you the shape of the data. If it is unimodal or has one mode, so highest point, a single highest point, and there's more or less the same on either side of that mode, the same amount of data roughly on either side of that highest bar, and it looks like a bell, then that's going to be a symmetric histogram. On the other hand, if it has a tail on the right, then that is a skewed to the right or right skewed histogram. The data is right skewed or positively skewed. This is because the mean is the balance point. If all these things had, all these bars had, like every height had a certain weight to it, a certain number of pounds, and you put them on a seesaw, the mean would be the balance point. So if you have a long tail on one side, the lever arm is longer, and so the fulcrum, or the thing that holds the two sides from teetering, is skewed towards that. Okay, so you always say if the data is not symmetric, you look at the tail, and if the tail is on the right, it's right skewed. If the tail is on the left, it's left skewed. All right, so here's an example of frequency distribution, and it asks how many classes. That's pretty obvious. You count them, right? But look, the upper class limit goes up to 7.9. It really goes to 7.9 repeating almost, okay? But none of the raw data that was collected was any more accurate than rounded to the nearest tenth. So if it was going to be in this first class from 1 to 7.9, every data point that's in that class would be between those two numbers, including 1 and including 7.9. But if, say, there was a data value 7.95, it wouldn't move up here. 7.95 would still be here because the class is from 1 all the way to 8, but not including 8. Okay? One thing we notice also when we have a frequency distribution for quantitative data is that we have lost some general information about the raw data. We know that there are 23 data points that lie between 1 and 7.9, okay? But we don't know what those data values are. That unless we look at the raw data, we won't ever know, okay? So although we've lost some information, right, we've gained, if we put in a histogram, the ability to see what the shape of the data looks like, what the mode is. It's easy to see that the mode here is this class, all right, things like that, okay? What is the class width here? You take the difference in the consecutive lower limits. All right, here's an example, all right, where we have to do the frequency distribution ourselves. Notice that all the data is rounded to the nearest tenth. So that's what our upper class limit is going to do. It's going to be whatever it is, 0.9, okay? Here it says you want the class widths to be 10 and 30.0 to be the first one. So if I start with 30, okay, the next one's going to be 10 more than that, and so on and so forth. So that's pretty easy. What would the upper limit be? It would be round to the nearest tenth, the closest you would get before you go up to the next limit. Okay, how do you find the frequency? Well, you look for, in this case, all the 30s, and really the only best way to do this is to check them off. So there's 1, 2, 3, 4, 5. So in this example, there would be 5 in that class, and you fill it all out. Okay, so that's how you do those ones. So I think those are the main points from section 2.2 that were asked about in the problem session. What else is there from the section? Oh, relative frequency was another question, okay? How do you find the relative frequency? Well, the frequency is the number of times, number of data values that are within that class. Relative frequency is that number divided by all the frequencies, the total frequency, okay? So if you add all these up, I think the answer is 65. So 9 divided by 65 would be the relative frequency as a number. Okay, so 13.8%, for instance. So what is the total relative frequency? That's always 1. And there's actually a important problem in your homework where that knowledge is necessary. So I think it might be this one. Is it? Yes. Okay. So here, this is a relative frequency histogram. Notice that if it were a frequency histogram, the shape and the height of the bars wouldn't change. The scale of the vertical axis would change. That's all. It's just scaled by the total frequency. But if you add up all the frequencies, you get, or add up all the heights of the bars, you should get the total frequency. If it's relative frequency, you should get 1 for like 100%. Okay, so if we have a bar missing, we have 0.1 plus 0.25 plus 0.3 plus 0.1 plus 0.1. That equals some number. Subtract that from 1, that gives you the height of the missing bar. Okay, the bar that reflects all the data between 1 part per million of silver all the way up to 2, but not including 2. Okay, be in this sample of rocks. All right. And of course, there's the choosing the number of classes. All right, that you need to make sure that you have enough classes so that the you're not losing so much. You want to have enough classes so that you're not losing too much information about your raw data, but too many classes makes it seem like you might as well just be looking at the raw data, and that's not as good. You're not getting the big picture. I talked about the shape. Okay, so if you have one mode, that's called unimodal. If on either side of that mode the graph looks pretty similar, as if you had put a mirror on that value, that would be symmetric or roughly symmetric. If it has a tail to the right, that's positively or skewed right. Tail to the left, skewed left, or negatively skewed. Okay, so that was section 2.2. Now, the bit about section 2.3, or sorry, 3.1, that has to do with mean, median, and mode, or measures of center. Everyone knows how to find the mean, okay? Mean is the average. You take the numbers and you add them up and you divide by how many there are. If it's a population mean or a sample mean, you do the same calculation, except they have a different symbol, which later will be important. All right, this sigma, uppercase sigma here, that is this symbol here stands, so sigma stands for sum, okay? So the actual definition of the sample mean, x bar, is that you take the sum of all the data values and divide how many there are, okay? So if you have a small number of data values, then doing it by hand, finding the mean and median is easy, okay? But if you have a lot of data values, then on your homework and tests, you can send it to Excel. If you're good at using Excel, I'm okay with that. You can use Excel. You're not allowed to use anybody else's help or any other website to help you during the tests. But if you're using Excel, that's okay. But a requirement of this course is that you have a graphing calculator, and the reason for that is because you can do all these things on the calculator. Let me show you how to do it, though, because the methods that I'm going to show you right now are going to be useful for all through Chapter 3 and basically for most of your first unit quiz. So we need to be able to put data into the calculator. We do that by going Stat and clicking Edit. Now, if you have old data, say there's old data into the list, you go up to the top and you hit Clear. Do not delete a list, you clear the list. All right, so here I'm going to put in these numbers: 20, 27, 32, 68, 40, and 30. Okay, it doesn't matter what order they're in. If you were going to do these things by hand to find the median, you would have to put them in ascending order from least to greatest. Okay, that's the biggest mistake with that, right? The median is the one in the middle, or in this case, there'd be two in the middle, so you take the average of the one in the middle. This is not necessary if you use the calculator, okay? You put it in there, and then you go to Stat, Calc, 1var Stats. If you have the new operating system or the operating system that is most prevalent nowadays, you get to this screen here, and you just click Enter, Enter, Enter to get to the end. And what they give you here is the mean, right? X bar is the mean. Here they also tell you what the sum of all the data values is. You might need that at some point. We don't need that in this problem. But say you wanted to find the total frequency, for instance, you might want to use this to add those all up for you. These numbers here are for later. Those are standard deviations. If you want to find the mean, the median, you scroll down. So the median is 31. All right, there's next to zero common mistakes with this 1var Stats thing. The most common mistake is you just type the numbers in wrong. All right, so make sure you double check that. Where there is common mistakes is if the data is grouped. So if we have a frequency distribution, then the data isn't just the numbers here or the numbers there. It's them together, right? This class has that frequency. So it's a weighted average if you wanted to find the mean, for instance. To do that, we still go to Stat Edit. We clear out our list, okay? But once again, we don't have the raw data, so I can't put in all the data values. I don't know what they are. But I do know that there are 4 that are between 10 and 20, right? So we're going to approximate the mean and the median by using the data value of the class midpoint with the given frequency. So the midpoint is the average of the consecutive lower limits. So I do 10 plus 20 divided by 2, right? So that's 15. And of course, if I did that for all these, you would see there's a pattern here. 35, 35. If the class widths are all the same, then the difference in consecutive class midpoints will also be equal to the class width. Note that to find the last one, I do 80, which would be the next lower limit, plus 70 over 2. Okay? So those go into list 1, the class midpoints. All right, so let me write that here. Class midpoint is the average of consecutive lower limits. Okay, so for instance, $20 plus 10 over 2 is 15 would be the midpoint of this one, right? So the class midpoints go into list 1, and then you put the frequencies into list 2. Okay, make sure they correspond with the same class. 10, 8. And the reason why we're doing this is because what we're actually calculating is a weighted average. Sort of like how we calculate your grade, right? Not every graded item counts the same. So a weighted average or weighted mean is the sum of the data values, right, times their frequency, all divided by the total frequency, or the sum of the frequencies, right? In other words, we're not counting the data value 25 once in my average. I'm counting it 11 times, right? Because 25 has a frequency of 11. That's all this is saying, all right? So to tell the calculator to find the mean, you need to tell it that it is grouped data. So you go to stat, calc, 1var stats. That means here your list or your data is still L1, but your frequency list is L2. Oops. So you go second 2. Okay? This is what I wrote in class, or what I did in class. I have the old operating system on my computer at work, which is a little harder. So in that one, I actually have to type in, when I go to 1var stats, it takes me to a different screen, and I actually have to type second 1 comma second 2, which makes this on the screen. Okay, if you have this version of the calculator, which everyone does, this is how you do that. When you click calculate, it tells me what the actual weighted mean is and what the weighted median is. Note that the mean and median are the same in this one because the data is relatively symmetric, right? Note that if the mean and median are about the same, and you have unimodal data, then you're going to have a bell-shaped curve. If the mean is bigger than the median, that means it's skewed to the right, right? Because the mean is always skewed towards the tails. Mean to the left means left skewed. Notice, if I had just done 1var stats, and I didn't change the frequency list, okay, so that's the default, it would give me the wrong answer, okay, because that is just taking the average of list 1 and not taking into account that there's more than one data value, more than one instance of that data value in our raw data that we're estimating. Okay, so that's pretty much what I wanted to show. So I hope this video helps. Thanks a lot. Bye.